Hello everyone, this is Group 2C, and this is our outline. In Assignment 1, we studied the components and microstructures of Ben & Jerry's ice cream, and in Assignment 2, we knew the information about the microstructures and rheology.
These tables describes how microstructures relates to physical property and sensory property.
When eating the ice cream, the consumer will experience these stages. These are measurements of performance done in industrial scale. We are going to test the performance of ice cream in terms of melting rate, spoonability, and hardness.
This is melting rate experiment. In this trial, the meltdown of ice cream can be quantified by determining the mass, then dropped from the product. We use matched screen electronic balance, spoon and plus box to measure it. The weight of melting part from 30 gram chili ice cream from 3 categories respectively. This experiment took 30 minutes for each kind of ice cream when it took out from. When the ice cream was removed from refrigerator, heat starts to penetrate into the ice cream because of the temperature difference between surrounding and product. Internal water will diffuse and mix with more concentrated serum phase. The diluted and low viscosity phase could easily be separated from subjective ice cream in some conditions, such as gravity.
Portion of ice cream is the most significant factor on the meltdown of ice cream, because the fat clusters can tightly link air-bomb protein, emulsifier, and salt together to hold the essential structure of ice cream dough. This is the reason why Peter has the highest figure in meltdown. Except fat effect, some other factors can contribute to the meltdown, such as overrun degree, microstructure of ice cream, natural properties, freezing point, and so on. This may be the reason for the different value in Ben & Jerry's and connoisseurs in this experiment, so further experiments on a microscopic basis need to be proceeded.
Hardness of ice cream is affected by the microstructures such as air bubble size and ice crystal size, and hardness directly affects scoopability. Microstructure affecting hardness are ice crystal, air content, and nature of the fat and serum phase. Welcome to hardness experiment. This experiment is designed to investigate the hardness of ice cream in texture. The hardness of ice cream is mainly affected by overrun and size of ice crystal. High amount of overrun will result in decrease of hardness, and the bigger the ice crystal, the harder is the ice cream. When the ice cream is hard in texture, it will be hard to spoon or scoop as well. This experiment mimics the mechanism of a penetrometer or puncture probe. The hardness here is simply measured by dropping a chopstick through a straw to the ice cream. The height will then be measured and used as a parameter of hardness. The deeper the chopstick penetrates into the ice cream, the softer is the ice cream. From the experiment, we can conclude that Ben & Jerry is the softest and Peter's is the hardest in texture. Consumers want scoopable texture ice cream, and the spooning is affected by the microstructures such as ice content, air content, and matrix viscosity, and also overrun. Right, going back with Elsa, I'm going to explain about this experiment. Basically, this experiment mimics the scooping or spooning of ice cream by consumers. A bucket of ice cream is passed through a hanging stick set in fixed height and distance. And the spoon is set to stand in the ice cream, and only half spoon is penetrated to the ice cream. When the spoon touches the stick, it will leak small amount of ice cream, and then we measure the weight of the ice cream. We do the same experiment for 3 types of ice cream: Ben & Jerry, connoisseurs, and Peters. the experiment, we can conclude that connoisseur is the easiest to spoon and Ben & Jerry is the hardest.
In conclusion, our experiment shows the connoisseur ice cream has the best performance in meltdown rate and spoonability, with competitive price of $1 per 100 ml. This ice cream brand is an overall best product compared to others. The performance of ice cream are major concerns of manufacturers and consumers alike. It is rare that only one type of microstructure or rheology measurement can reflect the performance of ice cream during interaction with consumer. Usually, it is a result of the combination of many microstructures and parameters, and this is why ice cream is a complex fluid.